This is Dr. P. Jaikanth Yadav, working as assistant professor at Institute of Aeronautical Engineering College. My course title is Complex Analysis and Special Functions. Today my topic is problems on complex line integral. So this is a continuation lecture of the previously started complex line integral. So we are doing complex line integral. Okay, so to perform line integral, we need a path. So here the path is given. In this problem, we have to evaluate integration of z square dz from 0 to z value 0 to 3 plus n along the parabola path x is equals to 3y square, 3 times y square. Okay, so first of all, we try to draw the graph of this parabola. Here, this is the complex plane. Horizontal axis we taken as real part of z complex variable. Real part of complex variable is x. Imaginary part of complex variable is y. Here, there is a relation between x and y is given, and we know it is a parabola. This is a parabola which is symmetric to which axis? It is symmetric to x-axis because the degree of x is 1. So it is the form of yes. This is y is equals to x is equals to 3y square. And here there are 2 points. Z is equal to 0 is this point. This is z is equal to 0. And we have another point 3, 1. This is the point 3 plus I is also called, if you write in coordinate form, it is 3, 1. It is 3, 1. Okay. So we are performing integration. This is the starting point and this is ending point, and this is the curve. The name of the curve is x is equals to 3y square. This is our curve. Okay, here thing is given here, complex function given in terms of z only. In the previous problem we calculated the line integral. There complex function given in terms of real and imaginary part. Real and imaginary parts are given directly. Here it is not given directly. We will write real and imaginary parts for the given complex function. Okay. So here the complex function we do not usually denoted with z, function of z. What it is? It is z square. Okay, so we know what is complex variable z. X plus complex variable in terms of real and imaginary part. Z can be written as x plus iy, because I am writing in terms of real and imaginary part. So whole square, because it is z square. Now you will have x square minus y square plus I times 2xy. You can see this is a real imaginary part and this one is the real part of the given complex function. Okay, now along the path, which path is given to us? The path is given as 3 times x is equals to 3 times y square. If we have this relation, then we can apply derivative on both sides. The derivative is required to calculate dz. Okay, so here it is derivative of x is equals to derivative of 3y square. Now it becomes 3 times into 2y dy. Nothing but 6y dy. You see, dx is 6y dy. Therefore, we can write dz. Dz we know. So dz is dx plus I times dy. Now I can write dx in terms of y. That is 6y dy plus I times dy. So simply how we can write it as 6y plus I dy. So dz comes in terms of y. Also, I want to write fz in terms of, with the help of x is equals to 3y square. I want to write fz. I can write 3y square whole square minus y square plus I times 2 into 3y square into y. Okay, we know now? Because fz is already we know this one. Now it will be 9 y to the power 4 minus y square. Next to plus I times 6y cube. So this is the real part and this is imaginary part. Here what you are observing, dz comes in terms of y and fz is also comes in terms of y. At z is equals to 0, we have what is x now? What is y? Because I am interested in y values. So here at z is equal to 0, y value is 0. At z is equals to 3 plus I, we have what is y? Y is 1. Therefore, y varies from here. Y varies from 0 to 1. Y varies from 0 to 1. Now, it is time to evaluate integration. Now, integral of 0 to 3 plus I z square dz. The function z square comes z square. Z square means f of z. F of z means we have to write 9y to the power 4, 9y to the power 4 minus y square plus I times 6y cube. Okay, this is z square on the curve x is equal to 3y square into dz. dz is dz is 6y plus I. 6y plus I dy. dy. And how is one on this path from 0 to 3 plus a, how y is varying? It is varying 0 to 1. Okay, 0 to 1. Now we will write there is two complex numbers here. There is one complex number here, also there is other complex number, and dy is multiplied. Now I will write a real parts first. 6y 9 y to the power 4 minus y square Next minus 6y cube. Okay, multiplied by dy plus imaginary part. So here I can write 9y to the power 4 minus y square next plus 36 y to the power 4. Here also dy, and we have integration from 0 to 1. Now you can take integration from 0 to 1. Here it is 54 y to the power 5 minus 6 y cube minus 6 y cube dy plus I times. Here you can get to y to the power 4 terms. We have to, it is 45 y to the power 4. Okay, I will take integral of this separately. Integration from 0 to 1. Here 45 y to the power 4 minus y square dy. Now we have to perform this. You see, this is the line integral of a complex function z square. We are reducing into two line integrals of real function. This is the real function, and here also we have real function. And if you see particularly, it becomes interval. Here y varies from 0 to 1. And the line integral is reduced to again integration along the interval. This is also integration along the interval. It is reduced. Now it is integration from 0 to 1 of 54 y to the power 5 minus 12 y cube dy plus I times integration from 0 to 1 45 y to the power 4 minus y square dy. I will evaluate this. You will have 54. If you after performing integration, you will get 1 upon 6 here, and 12 times 1 upon 4 here. Okay, this is our real part plus I times 45 1 by 5 minus 1/3. You get here only 1/3. So it is 9 minus 3 plus I times 9 minus 1/3. Yes, 1/3. Here you can get 6 plus I times 26 upon 3. Yes. So this is the value of the line integral of z square dz along the parabola x is equals to 3y square. The value is 6 plus 26 by 6 plus I times 26 by 3. This is the required answer. Next one is, we will do another problem. This. Here, evaluate integration of z bar, z conjugate, z conjugate square dz. Here we have to perform integration from z equal to 0 to z is equals to 2 plus I. So there are two cases here. Along the real axis to 0 and then vertically to 2 plus I. So I will do first case here. Along the real axis. So first of all, we have to identify there is a real part of z, which is x, imaginary part of x, z, which is y, imaginary part. Okay, now we need to perform integration. There is a point z is equal to 0, and we have another point 2 plus I. Here it is 2, if I take it is 2 plus I. Okay, I am taking it as 2 plus I. Z is equals to 2 plus I. So when we are performing integration, we need to perform first along the real axis. We need to go from 0 to 2. 2 is here. This is z is equals to 2. This is z equal to 2. We have to perform integration like this. We need to move from z is equal to 0 to z is equal to 2, and then 2 to 2 plus I. This. So what is the name of this curve? What is the name of this curve? This is nothing but y is equals to 0. And what is the name of this curve? Because on this curve, which is constant? X is constant. X is 2. At z is equal to x is 2, and z is equal to 2 plus I is also x value is same. Along this path, x value is same, which is x value is 2. Okay. So I am doing along real axis to 2, and then vertically to 2 plus I. Okay, so I am going to split this integral into two parts. Okay, so I will do that later. First of all, here, what is f of z? Which is conjugate of z whole square. So what is conjugate of z? Conjugate of z in terms of real and imaginary parts. It is x plus iy conjugate then square. It is x minus iy whole square. So what you can get here? It is x square plus y square minus 2i xy. Okay, you can observe there is imaginary number. Okay, and this is f of z. For z bar square, there is a real part and we have imaginary part. Now the line integral is splitting into two line integrals. We need to split into two line integrals. So I'm going to split the integral. We have integration from 0 to 2 plus I z bar square dz can be written as 0 to 2 z bar square dz plus integration from 2 to 2 plus I z bar square dz. Okay, now I'm going to evaluate first integral. Here, now integration from 0 to 2 z bar square dz along which path? Because from 0 to 2 we have to take y is equals to 0. So what you can expect along y is equal to 0. So dy becomes what? Dy becomes 0. So that dz becomes dx plus I dy, which is dx only. Also z bar square, which is x square plus y square minus 2yxy. Okay, now I can write it as, since y is 0, I will have only x square minus 2ix into 0. Here I will get only x square. Okay. Now I will do what I will do. Here I will calculate z bar square into dz. Here we already calculated z bar square on the curve, which is x square into dz. Dz is nothing but dx. We calculated dz. It is dx. So that is what is simply x square dx. Here we are getting this product is in terms of x. In this path, on this path, how x is varying? At z is equal to 0, x value is 0. At z is equal to 2, x value is 2. Okay? X value is 2. So here x varies from 0 to 2. Therefore, integration of 0 to 2 z bar whole square dz can be written as z bar whole square dz, I already know, which is x square dx, and integration we need to take from 0 to 2. So this is simply what? It is x cubed by 3. And x varies from 0 to 2. This is 1/3 into 8 minus 0. It is simply 8 by 3. Okay. So keep it is 1, or you can write that is integration from 0 to 2 z bar whole square dz can be written as 8 by 3. Make it is 1. And we need to evaluate along. We have to evaluate this integral along x is equals to 2. Okay. integration of z bar whole square dz, and z varies from 2 to 2 plus I along which curve? Along x is equals to 2. Along x is equals to 2, what is dx? Dx becomes 0. So that dz becomes, we know dx plus I dy. So here dx is 0, it means this implies dz is I times dy. Okay, this is required to us. Now I need to evaluate z bar square. Z bar whole square. So it is x square plus y square minus 2i xy. 2i xy. So on the curve x is equals to 2. It is 4 plus y square minus 4i y. Since x value is 2, that's fine. Now we calculate z bar whole square dz is 4 plus y square minus 4i y into dz. dz is nothing but we calculate just I times dy. I times dy. So it is simply, I will write first the real part. It is 4y dy plus I times 4 plus y square dy. Okay. Here if you observe this, the product of these two terms comes in terms of y. Okay, in terms of y. How y is varying on this path? In this path. From z is equal to 2 to z is equal to 2 plus I. How y is varying? At z is equal to 2, y is 0. At z is equal to 2 plus I, y value is 1. Okay. So therefore, here integration from 2 to 2 plus I z bar whole square dz, I am writing as 4y dy plus I times 4 plus y square dy. Here we will take integration y variation from this point to this point. It is from 0 to 1. Now you can get it as 4 integration from 0 to 1 y dy plus I times integration of 4 plus y square dy. Okay. So we know it is, the first term is 4 into 1 by 2 plus I into 4 plus, here it is from 0 to 1, 4 plus 1 by 3. So simply we got as 2 plus 13 by 3, 13 by 3 I, 13 by 3. Therefore integration from 0 to 2 plus I z bar whole square dz is equals to, we calculated integration from 0 to 2 z bar whole square dz plus integration from 2 to 2 plus I z bar whole square dz. So we know the first value is 8 by 3. Here 8 by 3 plus, and the second one is 2 plus 13 by 3. This one 2 plus 13 by 3 I. Okay, so you will get 14 by 3 plus 13 by 3 I. So this is the solution. If you perform integration along the path, when you moving from 0 to 2 plus I, you have to move along real axis up to 2, and then you have to move vertically to 2 plus I. So if you evaluating line integral in this way, you will have 14 by 3 plus 13 by 3 I. Now we have to do the same line integral along this path. Here we have 2y is equals to x. 2y is equal to x. So I already explained, as we always write the given complex function. Here complex function is z bar square. You write in terms of real and imaginary parts. After that, you take the curve and apply the conditions. Okay, in this case B is we need to take 2y as x, or you can take x as 2y. Okay, and we also know 2 points on this path, and x is equals to 2y. See, this is x is equals to 2y path. This is x is equals to 2y path. So now very clear, we are performing along in this direction. This is the starting point and this is ending point. Okay, right. So in this way we have to evaluate. In the case B, there is a real axis and this is imaginary, and we have z is equal to 0 here, and there is a point z is equals to 2 plus I. You will take a straight line path. The path name is x is equals to 2y. Okay, this is of case B. We have to evaluate in the similar manner along this path. Next integral is this one. Here we have to construct a line passing through these 2 points. Okay, in this way we have to construct a line passing through these 2 points. There you can get a path, and we need to write the integrand in terms of real and imaginary parts. Okay, then here we know the path names. Here we know the integrand in terms of real and imaginary parts. Use the above procedure and you can get the required solution. Okay. So this is. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.